Hey everyone, welcome back to my channel EduVibe. In today's lesson, we will start with the another topic of the forces and fields, which is grade 12 physics. In the previous lesson, we will do the Coulomb's law. In today, we will do the Coulomb's law again, but in the vector analysis. So Coulomb's law is like we will do in the vector 2 now. So we'll actually focus on the questions because the vector analysis is more important than the Coulomb's law separate questions. That vector questions comes in examination or in diploma. So let's discuss how can we deal those things when we have a vector in Coulomb's law. So point charge B with a charge of minus 3.0 10 raised to a negative 6 coulombs is placed as shown below between the point charge A with a charge of 1.0 into 10 raised to negative 6 coulombs and the point charge C with a charge of 2.0 into 10 raised to minus 6 coulombs. We have charge A, charge B and charge C. We have all charge over there. The magnitude of the electrostatic force between the point charges B and C. So from the B and C, the electrostatic force is 2.40 newtons. We have to determine the net electrostatic force on the negative charge. So negative charge is this. So we have to find the net one. So to find the net one, net means we have found the total charge. So we have that from B to C, we have that electrostatic force, which is about 2.40 newtons. But we don't have from this to this. We have to find from the A to B. When we find that force between electrostatic force between that two charges, we will get the net force from here. So in this type of every time we have to firstly make the free body diagram. So what is free body diagram? That how the question works. If we have something over there, if we have a mean point over there, the charge B to C goes over there. So from force C to B we have over there, and here we have force A to B. So we will take one as positive, one as negative. So in that case we calculate the AB. So we take this as positive, so left as positive and the right as negative we take in that case. So this has to be know that because the electric force is a vector, so we have to make sure about that sign convention in this when we find the net one. So first we have to find the force between the A to B, charge A to B we have to find. So for force from A to B, we know that formula is QA QB. That two charges we have number A and B, so we take A and B, and we have R square of A to B. So R square we have already given this one, 5.00 into centimeter squares. So for this one, so the force is equal to, we have now K 8.99 into 10 raised to 9 Newton meter square upon C square. QA we have given to us, which is 1.0 10 raised to negative 6 coulombs, and we have this QB is 3.00 into 10 raised to negative 6 coulombs. When we do this, we have to take this in meters because in centimeters. So when we just divide this by 100, we get 0.0500 meters. So we take this 0.0500 meter. We have to take care of this. When we find this, we get about 10.788 newtons. So we get the force from A to B, and we have that force from C to B, which is 2.40 newtons. We have to take this in negative because this goes on the right direction, and we take right as negative. This remains in positive because this is the left one. So to find the net one, we have to do F of A to B plus F from C to B. So this is equal to, when we plus 10.788 newtons and negative of 2.40 newtons, we get about 8.39 newtons in positive. So this means in the left direction. So this is your net force in the left direction, net force which you have to calculate. So this is a simple kind of question. We have one C to B force, we have to find an A to B force. So when we find that, we find the net force. Sometimes you get the more complex one like this. So you get type of the angles. So this type of angles we have. So this thing we have a 3-point charges now. So this is the simple one question. Like we have AB and CB and we find the net. Now we have to find the both ones. Once we get the both, then we'll find the net force magnitude and the theta 2 because this is the angle now. As we do in the momentum and impulse, we do the right angle iterations. This is that kind of question, but in the electrical iterations now. So we have a 3-point charges, each with plus 30 microcoulombs. So everyone has the same charge. Arranged in the right angle as shown below, determine the initial electrostatic force on charge B. So this is not a matter which they tell us charge B or charge C. We have to find the net one. How can we find that? So let's find it out. So we have everything else, everything we have over there. We just convert the centimeters into meters. So for this, we get about 0.050 meters. For this, we get 0.070 meters. Now, first we have to find the force between A to B, then B to C. Then we'll find the magnitude of the net. So to find this, let's move on to this. So find from A to B. So this is K, A, Q, A, Q, B. And we have R square AB. So this is equal to 8.99 into 10 raised to power 9. The square, C square. Everyone has the same charge, so we directly do 30 into micro has the value of 10 raised to power minus 6 coulombs. We get the directly square of this because QA and QB are the same. So R square is 0.050 meter, should be in meter, and then square of it. And when we calculate this, we can get about 3236.4 newtons. Same for the CB. So QC QB is equal to RCB square. So when we find this, K is again the same, and that QC QB is remain the 30 into 10 raised to power minus 6 coulombs squared, and that whole divided by 0.070 meters square, which is that value. So from here, when we calculate this, we get about 1651.2 newtons. So this is for force from A to B. This is from force C to B. Now we have to find the magnitude of the net one, and for this we have to find the what is like our vector looking like. So first force it goes from A to B, and this goes from C to B. So from A to B we have like this. This is force from A to B. This is goes from C to B, and this is our net one. So if we have right angle to angle, we have to do like this, and we also have to find the theta 2. What is that theta? So that's how we have to find. Now we have to find the net one, then we find that theta. So for this is again simple. So as we do in the momentum and impulse, we deal with the vectors. Same thing we have to do in this. So from A to B square plus force from C to B square. So the net one is equal to AB, we have 3236.4 Newton squared plus 1651.2 Newton square and whole root. So the net one is equal to 3.6 into 10 raised to power 3 newtons. We find the magnitude of the net force. Now for theta, we do tan of this upon this, CB upon AB force. You all know how can we deal this? So this is point this one and 3236.4 newtons, and we do the tan -1 of this. When we do, we get about 27 degree. So what is the angle? So this is go north and then those east. So it's north of east. So we have to find that we have to arrange them all. We want to set this, so 3.6 into 10 raised to power 3 newtons, and we have 27 degree north of east. So that's how you have to find that when we have a this type of thing. So this is the simple type of thing we deal in this. First version we do simple thing, then we move on the more complex, which is the right angle one. And when we do some practice questions, we will do more complex one. And in also in electric fields, when we do electric fields, the vector analysis again, vector addition then comes, and we will do with the more and more complex. This is also very important because in this we find the net one. Net one always come in like in MCUs or the numeric response. So you have to know that how can we deal with this. You have to just know about the Coulomb's law and how can we have that. We have to find the magnitude of the net one and how to find the angle. This angle and magnitude we have to find in only like when we deal with the right angles. So that's how you can deal with the vector analysis in the Coulomb's law. So that's all for this lesson. Learning is simple with EduVibe. Learn smarter but not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. And in the next video, we'll do some practice questions of this part, which we do in the 3 lessons of the so far we done in our forces and fields. We do a practice questions. We cover more and more complex questions in every topic, and then we move on to the next part of this lesson, which is electric fields. So when the actual forces and fields start is from the that lesson. So see you in the next lesson. Till then, stay attentive with EduVibe.